Good morning, friends. Indeed, I am very happy to be here for my course Flight Mechanics. I am Dr. Yagya Dutta Dwivedi, professor from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. As of now, in my previous class, I have discussed about how the lift is generated, how the drag is generated, airfoil nomenclature, different controls, different theories of lift, like bound vortex theory, Venturi theory, skipping stone theory. These all theories we have seen. We have also discussed about drag, how the drag is produced. In today's class, we will be covering these topics, that is course overview, course objectives, introduction to flight mechanics, performance requirement, and mission profile. So here, flight mechanics is the science that investigates the performance of the aircraft as applied to flight vehicle and to provide a clear understanding of related topics, specifically on the aerodynamics, propulsion, performance and stability, and the flight control. The course introduces the fundamental principles of aerodynamics and propulsion of aircraft performance. Okay, so the fundamental principles of aircraft and propulsion for aircraft performance in classical flying stages, the different regimes of aircrafts and performance requirements at various atmospheric conditions, the mathematical model for various types of maneuvers, safety requirements during takeoff, landing, and better performance and stability. Flight mechanics is the study of forces that act on the aircraft in flight. This subject is broad heading that encompasses three major disciplines, namely airplane performance, flight dynamics, and aeroelasticity. If you talk about the aircraft performance, airplane performance deals with the determination of performance characteristics such as range, endurance, rate of climb, and takeoff and the landing distance, as well as flight path optimization. Flight dynamics, it is also called aircraft stability and the control. Flight dynamics is concerned with the motion of airplane due to the internally or externally generated disturbances. Then if aeroelasticity deals with both static and dynamic aeroelastic phenomena. Basically, aeroelasticity is concerned with phenomena associated with interaction between inertial, elastic, and aerodynamic forces. So, inertial, elastic, and aerodynamic forces. So now, what are the performance requirements? So, the performance requirements are range, takeoff distance, stalling velocity, endurance, maximum velocity, rate of climb. Then we have some combat performance, maximum load factor, service ceiling, cost, reliability and maintainability, and the maximum size. So we should go with some basic definitions of this performance. So we can see that aircraft range is measured in terms of distance and qualifies how far an aircraft can fly based on a given amount of fuel available. This, with a given amount of fuel, how much amount of distance, how much kilometers or miles your aircraft can go in a certain condition. That is called the range. So range depend upon the distance with a given amount of fuel of the aircraft. And if you talk about the endurance is the time. In aviation, endurance is the maximum length of time that an aircraft can speed up in a cruise flight. So how much time it can fly with a given amount of fuel, that time matters in this case. Stall in aviation, when the angle of attack suddenly increases beyond a certain point such that the lift begins to decrease is result in stalling. So whenever you increase the angle of attack, and as you increase the angle of attack, for certain angle of attack, your lift will be increasing. But as and when you increase further, then lift will not increase, but it start decreasing. That point is called the stall point, and we should not go beyond that point. In fact, from there some 15 to 20% below, we have to fly. In case of emergency, in case of some sudden gust and all, we should be able to control our aircraft for this purpose. Rate of climb. The rate of climb is the rate of change in altitude. So rate of climb is per unit time how much altitude or how much height your aircraft is going. So it is like this. So this height, how much time it is vertical height your aircraft is covering in a given time. That is called the rate of climb. Another term is load factor. It is the ratio of the lift of an aircraft to the weight of the aircraft, and so this load factor is designated as a small n, and this is a lift by weight. So this is your load factor, very important parameter for aircraft performance. Service ceiling. The service ceiling is the maximum usable altitude of an aircraft. So it is the maximum altitude up to which aircraft maintains its designed rate of climb. And the absolute ceiling is the highest altitude at which an aircraft can sustain a level flight. So up to that altitude, it can maintain a level altitude. But the service ceiling is it can maintain some rate of climb. Another term is reliability, is defined as the probability that a product, system or the service will perform its intended function adequately for a specified period of time or will operate in a defined environment without failure. So combat is for the fighter things, fighter aircraft. For military aircraft, we use this combat word. Combat is the most commonly used in a military context to refer to the active fighting among opposite armies or an aerial battle between fighter planes. So next I will discuss about aircraft mission profile. All aircrafts having some designated phases of the flight, and they are performing some given mission. Here I am showing the different 4 types of mission profile for different aircrafts. A typical mission profile for various types of aircraft as shown in the below. So number 1 is a simple cruise. So in this what happened? Your aircraft is here. Your aircraft is here on the runway and it is start speeding. So it is called the takeoff from 0 to 1. After reaching to 1, it has to increase the angle. Then initially it will go like this. Then it will increase. It is a climb. From climb it will reach to the cruise. So in the same altitude it will go for a long distance. As and when it is required to land in the same runway or in the other runway, it has to descend. So this is the descent. And if the pilot is not giving this, ATC is not giving permission to the pilot, ATC will tell to go around on the runway, on the airport, and your aircraft will go like this, like this, like this. Till the time ATC is not permitting, this is called the loiter. And from there it will come down to the runway and it is the landing. Your aircraft will reach here in this way. So it started from here, it is reached here. It may be the same runway or in another runway or some another district or another city. So this is a simple cruise flight. Normally for the general aviation aircraft, we use such type of landing and performance. So here we have that takeoff, climb, cruise. 0 to 1 is takeoff, 1 to 2 is a climb, 2 to 3 is a cruise, 3 to 4 is a descent, and 4 to 5 is a loiter, and 5 to 6 is a again descent, and from 6 to again 0 it is a landing. So like this we have to perform. So this is a simple cruise. Now I will go for another type of commercial aircraft, commercial transport, bigger aircraft like Boeing, Airbus 320, 380, Boeing 757. These all bus, they will go from one city to another, from another to another, from another to another. Like this, they can go for different airports and all. That time we use such type of mission profile. So in this same way, it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, just I give the number. So from 0 to 1, it is a runway, running the aircraft on the runway. 1 to 2 is a climb. Aircraft has to reach at a certain height. From this 2, it is a cruise. It will maintain same height as per the best economical condition. It will go to the 3. From the 3, it will start descending up to 4. And if your aircraft is not permitted to land, there is some another aircraft on the runway, or they are landing, so ATC will give you to loiter around the airport. It will give some height. In that height, you have to just make a circuit, make a few circuit. As and when you are permitted to land, ATC will inform to land. It will approach again from 6, and it will land here and park, deboard the passengers or the cargo. After some time, it will take off, it will divert, then it will go to 9, again it will descend, again the loiter, if then again 10 to 11 descend and again land. So number of flights you can shortage, you can plan. For the commercial, they are very big, they have sufficient amount of fuel, they need not to take the fuel, and some maintenance work also not required. They will board or the deboard the passengers or the cargo, they will deboard. Accordingly, they will do the work. Now I will go for the third one. It is low level strike airplane. These are for the striker aircraft, for the military aircraft, for Indian Air Force or other air force of the world. They use such type of aircraft. So they will take off like the previous one. They climb, they will cruise, they will loiter, they will drop the weight or the bombs here. Then again they will climb, again cruise, they will loiter, and many times they can do like this. It is not only once. They can go, they can climb, drop the bomb, again go, they can go like this. Different maneuvers they will perform. And this type of striker aircrafts are used for defense purpose, for air forces, world air force. They have like this, and they can drop the bombs or some other things, for the torpedoes, from other activities for naval purpose. Then air superiority aircrafts, they can do the combating, the dog fighting and other things they can do. So they will not come down very low, but from that height only they will drop the missiles, they will bombs, some rockets, some other things they will have. This is the for the your air superiority mission profile is performed in this way. I will also discuss about some parts of the aircraft. It is very much essential that before I proceed further, I should start about the components and their functions. So here I will start with the cockpit. In the cockpit, your pilots are sitting, and it has the all type of controls, cockpits, all the instrumentation is here. Here used for command and the control. And this full body, a big part, a cylindrical part is a fuselage. It is called body, holds things together and carry the payload. Then we have here wing. In the wing we have the slats. These slats are at the leading edge and they change the lift. Then we have the spoilers on top of both the wing, here also and here also. We have the spoilers. This change the lift, drag and the roll condition. We have the aileron. The aileron will facilitate the rolling of the aircrafts. Flaps, I have discussed in my previous, that flaps are used to change lift and the drag as per the requirement. Then we have here elevator. Elevators are used for the pitching. Nose up and down is done by the elevator. Rudders are used to change the yaw side to side. Motion can be performed. Vertical stabilizers are used here. Control yaw is used. Horizontal stabilizers control pitch is used. Wing generate the lift. Jet engine generate the thrust. So like this you can use the different, and these are the purpose of these are the books which we can follow. Thank you very much for joining. Any questions you are welcome to ask. I also request to be tuned for my next lecture about flight mechanics. Till then, goodbye and thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.